Hi, I'm Pat Kelly. Okay, in this problem, they give us these vectors u and v, and they ask us to find u cross v, but then also to show that that cross product ends up being orthogonal to each of our original vectors. So we'll do that, but let's first get the ball rolling on this cross product. So to do your cross products, hopefully you've been practicing, and if you've been using this determinant form, the first row is always I as a vector, j as a vector, and k as a vector. And then the second row in this determinant form is 1, minus 1, 0. Your third row in this determinant form is just the other vector, the components 0, 1, minus 1 in this case. And then you want to use like a cofactor expansion approach to evaluate this and get our cross product. So the cofactor expansion, I'm going to go across the top row and get my I vector and have it multiply by the determinant of a submatrix, which in this case will look like minus 1, 0, 1, minus 1. Right? Your submatrix is coming from covering up row and column that have I. Minus, the minus is part of your cofactor expansion. And then I'm going to have my j vector multiply by the determinant of the submatrix that results when I cover up that column and the top row. So I'm looking at 1, 0, and 0, negative 1. And then finally, plus my k vector needs to multiply by its determinant of the mini matrix here, 1, minus 1, 0, and 1 submatrix. Okay, now you do your little crisscrosses for each of those determinants. So let's see. Negative 1 times negative 1 is 1. Subtract 0 times whatever is going to be 0. I vector. Subtract. Crisscross here is going to be 1 times negative 1, which is minus 1. Subtract 0. And that's going to multiply by the j vector. Plus, crisscross here is 1 minus negative 1 times 0. There's another 0 for you. Times that k vector. Let's clean this up and see that this ends up being what? Just I minus a minus, so that'll be plus 1 times j plus 1 times k. So just the k vector. Or if I even write it this way, we're going to have components of 1, 1, 1. That's convenient. Convenient to remember, because now I'm going to slide over here and do the second part of my work, where they wanted me to confirm that that result is going to be orthogonal to each of these initial vectors, which means I need to do u dot with the result of our u cross v, right? So for me, my u is 1, minus 1, 0. And I'm dotting that with 1, 1, 1. I knew I'd be able to remember that. And that equals, your dot product is when you multiply the corresponding components. So 1 times 1 is 1. And then you add the result of multiplying the next pair of corresponding. So 1 times negative 1 is going to be a negative 1. And then add and multiply the 0 times the 1 here, which is going to be 0. See what that equals is 0. A dot product of 0 means you're orthogonal. So we confirm that one. Let's also do the v vector. Let's jump right into the component version of this and dot that with our 1, 1, 1. And do that same pairing up, multiplying, and adding in between. 1 times 0 is 0. Plus 1 times 1 is 1. Plus 1 times negative 1 is negative 1. And that also yields 0. Dot product ending up being 0 means the vectors are orthogonal. You're done. Go try some on your own.